Okay, we're in section 10. And again, it's on the SAGE stuff. All right. So again, I'm hoping that if you've been paying even mild attention, that you get some idea that we're talking about software at this point. And you're free to use the online version, or if you have it installed, you can use a terminal or a Sage notebook, whatever way you're comfortable doing it. I really mean that. A lot of times, what you're going to end up in a career where you're given no choice. All right. And I gotta be honest with you, that's not the kind of thing you want to go towards in life where we have no choice. Unfortunately, for education, sometimes you're ending up at schools that provide no choice, no level of creativity on your end. Now, I say Sage, and I'm not saying it has to be Sage. You could be using MATLAB, you could be using Wolfram Alpha, you could be using Mathematica, or there's really literally hundreds of different applications out there, including coding on your own to get answers to numerical problems. And that's what we're doing. We're using this as a computer algebra system to get answers. All right. So I'm going to just simply say, I want to try Sage. All right, reset. I guess we've been doing that really way too long at this point. And then X is a variable. Again, for the students who are taking computer science, you know how important it is to define your variables for using them. Oh, look at this one over here. It looks sort of familiar. Solve arctan of X. When you use a double equal sign, I'm saying it's an equation. Equals our cosine. This goes back to Math 120, and you need that experience to do well in Math 121. Let's see what happens. Wow, that's weird, isn't it? It just gave me back the original equation there. And that I have to be honest with you, that's really strange to me. All right. Basically, it's saying to me, I don't think I can do it. Right. So I'm going to have to plot this now. So plot. And someone says, why do you plot? I want to visualize what's wrong with that answer. Why couldn't it get an answer over here? So plot, what do I want to plot? Well, two functions. I want to plot the arctangent. I know what that looks like. I can certainly do it by hand, by the way. And I want to plot the arc cosine. And I know what that looks like too. And I'm ready for that as well. I know what these things look like. I've taken Math 120. And let's see what happens. I don't know. Wow, I see it. So when I'm looking at this picture, I want to point out what I am seeing. And someone says, I don't even know what the hell I'm looking at. Well, maybe you didn't study Math 120 hard enough. And that's a problem. I really mean that. You don't know how big of a problem this is. Students, I'd say it's not just at Essex, it's everywhere. I think to myself that college is almost like, a lot of students think if they just go to college, that somehow their lives will get better. And I got to be honest, if you go to college and you're not engaged in your studies, life actually gets worse. Because what happens is this: your expectations shoot up when you get out of college. Your expectation is you're going to get a good job that pays well. And if that doesn't happen, you're going to be horribly disappointed. I routinely meet students that I've had before where their dreams didn't come true. And it's heartbreaking. But I'll be honest with you, I routinely meet students where their dreams have come true, where they've actually find productive employment in a field of their choice where they're doing well. What do I mean by well? They feel respected at where they work and they feel compensated. I can't say compensated at the level they really expect to be compensated at, but enough where they're not crying every day. All right. Again, no one's satisfied with their paychecks. Yeah, I shouldn't say no one. Very few people are satisfied with their paychecks. What's this all about? Did you spend the required material in Math 120 to understand what these two graphs are? And I hope you did. This blue curve is a partial region of the arctangent function. And this green curve is the full picture of the arc cosine function. Do they agree somewhere? Are they equal somewhere? And I notice they are. I notice they actually touch one another somewhere. And where would that number be? Kind of looking at it, I'm going to say the X value for that would be around, let's see, 0.5, 0.6, 0.7, around 0.8. Now, by the way, when I say around 0.8, I'm not going to testify it's 0.8. I'm just going to say it's around 0.8. That's where they intersected. That's the X value. Now, someone says, what's the Y value? And I'd say about 0.7. But really, what I'm mentioning, what's the X value they agree? I'm going to say around 0.8. All right, let me go back to my code. And I'm going to talk about the next thing in my code. All right. And I'm going to talk about this. And remember, I believe there's a solution around 0.8 after looking at that picture. I actually believe it. I believe those two curves touch at 0.8. Now, you spent a lot of time in Math 119 and 120 visualizing solutions to difficult problems, by the way. All right. But let me take a look at this. And what does this one say? Find root. Someone says, what's that about? That's trying to find a solution to the equation, right? It's trying to find a solution to the equation. But when I use find root, I'm going to tell you where I believe the root is. And we did this in Math 119 for those students that have taken me in 119. And by the way, I do actively try to get other teachers at Essex to talk about the use of software, but a lot of them don't want to go anywhere near it. All right. But I now need to tell them where I believe the root is. Now, remember, I believe the root was 0.8, but all I got to tell Sage is where the root occurred. Let me go back to my picture. And I'm going to say, to play it safe, I'm going to say this root, in other words, where these things agree with one another, occurs between 0 and 1. Now, someone says, well, I can get a better bend to that. I could say between 0.5 and 1. You could even get a better one than that. You could say 0.6 and 0.9. There are many intervals where that solution exists. I'm just going to play it safe and say between 0 and 1. Let me do that for you. And again, I want to point out what we're doing. We're looking at code. Code's over here. They want to look for the root between 0 and 1. All right, and go back to my my Sage instance, okay? So I'm going to say between 0 and 1. Now, before I hit the return button, I want to go back to my picture. And this is really important, that you can look at something and know approximately what the answer is. Mistakes can happen, by the way. I'm thinking the X value here is 0.8. Let's see what happens. Wow, I was really close. All right. Now, someone says, is that true? Is that really the root? No, it's not really the root. It's just damn close to that. What do I mean by that? I mean the arctan of this number over here. Well, I did a mistake there. Sorry about that. Is that number. And the arc cosine, watch this. That number should be approximately the same. I can't guarantee they will be the same though. Are they approximately the same? My God, they're exact to the level of precision that Sage can handle, right? To the level of precision. All right. I'm not saying they're exactly true, by the way, right? I'm just saying to the level of precision, they sure do appear to be the same number. I want to try one other thing with you. This is Boolean. And I want to see if this is equal to this. It says it's true. Within the machine's level of precision, these are the exact same numbers. And that's important to know. The truth of the matter is, though, that's an approximate truth. It's not the exact answer to it. All right. The exact answer would be quite difficult to come up with. All right. So that's about it for that problem over there. I think it wasn't too much Sage code there. All right.